We're asked to solve this system of linear inequalities, and we're going to follow the same steps we did on the previous page, or the previous video. Step 1, we're going to do the sketch. So let's look at A first. We're going to sketch y equals, not less than, but equals 1/2 times x plus 1. Well, it's already in y equals mx plus b form, so we'll use that method to do this sketch. We see that the slope m equals 1/2, that's rise over run. And we see that a point on the graph is the y-intercept. It's the ordered pair 0b, so it's 0, 1. So that's all we need to do that graph. Now let's do B. B is y equals -1/3 times x plus 1. That's already in y equals mx plus b form, so we'll do the same trick. The slope here is equal to -1/3, rise over run, and the y-intercept, 0b, is the ordered pair 0, positive 1. Put those two graphs together. But before we do it, let's do step 2 real quick. In both cases, we have the inequality sign less than. There's no equal portion. And that implies that both of the graphs will be dotted, not solid. Okay, so let's go ahead and draw those graphs. Okay, definitely going to have this point, 0, 1, in both of our graphs. Let's just do A first. Let's graph A. We're going to use rise over run from this point that we just graphed at 0, 1 to get to a second point on the graph. Rise over 1 is rise 1 unit up to the 2, and then move to the right 2 unit. 1, 2, 2 units. That will take me here. So we rose 1, and then we ran to the right 1, 2 units to this second location. Connect those 2 points together with a dotted straight line. Dotted through those 2 points. Arrows on the end. Label this as our inequality, our equation A. The equation B has the same point, 0, 1, but then it has rise over run, -1, and then to the right 3. So it takes us to this point. Connect these 2 points together to get our second equation. Second equation, and that is equation B. Okay, step 3. You see we did the graphs already. We graphed the 2 points and connected with a straight dotted line on each case A and B. Now we're going to test a point, and we have to name our test point. Our test point, let's see, is my favorite test point available? Yes, it is. It's 0, 0. I'm going to put a circle around that. Now remember, if either of those lines, those dotted lines, passed through that point, I wouldn't be allowed to use it. I'd have to choose a different point that lived off of the graphs. I'm working on testing a test point for A, because we're going to do each one of these. So I choose this test point that lives off of A. It's the ordered pair xy equals 0, 0, and I named it. It's very important to name your test point. Now I'll put a cloud around it. Let's test it in inequality A. Does it satisfy inequality A? Y less than 1/2 times x plus 1. Plug in x equals 0, y equals 0. Is 0 less than 1/2 times 0 is 0 plus 1? Is 0 less than 1? And the answer is yes. Okay, so what does that mean? That means shade the same side as a test point. Same side. Okay. So that means I'm going to put little baby arrows because it will get way too messy if I put shading. So I put little baby arrows on inequality A's graph to indicate that I'm shading on this side of the graph all the way down. Now let's do B, testing B. That's the inequality y is less than -1/3 times x plus 1. And it looks like we can use the same test point, 0, 0, because it also lives off of the graph of the inequality B, the B line, the dotted line. Okay, so our test point here is the same test point, and we'll plug it in. 0, is that less than -1/3 times 0 plus 1? Is 0 less than 1? And the answer is yes. Okay, and that applies the same thing. We're going to shade the same side. And when I say same, I mean same side as the test point, the same side of the graph, of the line as the test point lives on. Okay, so put little baby arrows on the graph of B pointing to this side, the lower side of the line, because that's the same side that the test point 0, 0 lived on. Now you can choose a different test point, but you still have to do the little arrows. Now I'm going to conclude step 3. I'll write here step 3. The conclusion will be the solution. So I'm going to shade the common region. And when I say common, it's the common region where we would have shaded with the baby arrows. So this takes a little examination here. Which region is shaded by both the A arrows and the B arrows? And I'm going to show you. It's this, all of this, okay, and more. It's all of this. So I have cordoned off this section of this graph and shaded it. And all the values in this shaded region, and it's a mess. I want to box that graph because all the values in that shaded region represent ordered pair solutions to this system of inequalities.